Dear friends, welcome back to Civil Conclave presentations. Today we are going to discuss about how to prepare the bar bending schedule for a one-way and a two-way slab. Before getting to calculate, before understanding how to calculate the bar bending schedule, you must know whether the slab is one-way or a two-way slab. What are the methodologies? One-way slab, Ly divided by Lx is greater than 2. Ly means the longer span and Lx means the shorter span. Two-way slab, Ly divided by Lx is lesser than the 2. In one-way slabs, main bars are provided in a shortened direction, that means with the crank bars, and distribution bars are provided in a longer direction, which is a straight bar. In a two-way slab, main bars are provided in both the directions. See, this is a one-way slab, this is a two-way slab. One-way slab is a one direction and two-way slab is a two directions. One-way slab. The concept of the one-way slab is the main reinforcement is one direction for a one-way slab. In one-way slab, the ratio of the longer span to shorter span is equal or greater than 2. The concept of the two-way slab. Main reinforcement are in both the direction for a two-way slab. In two-way slab, the ratio of the longer span to shorter span is lesser than the 2. Distribution bars. These bars which are straight, which is known as a distribution bars. Main bars, they are cranked bars. Main bars are cranked at an angle of 45 degree with the length of 0.42 d. Therefore, d is equal to depth of the slab minus top cover and minus bottom cover. Extra bar. The extra bars are provided at the bottom of crank bars to maintain the framework of the slab. The length of the extra bar will be L by 4, that is the length divided by 4. Slab reinforcement details. See here, I show you the slab details. This is what a longer span which I called as a Ly. This is Lx, this is a shorter span. Here you have a beam. These are the slabs, okay. Slab reinforcement. See the main bar at the bottom. Distribution bars are at the top. This is the crank bars. This is divided by L by D, okay. Distribution bars. These bars are straight bars. Main bar. These bars are crank bars. See here, I can show you. This is the crank bars. You can see it here. This is the crank bars. These are cranked at 45 degree to a minimum length of a 42 d. This angle of crank is 45 degree. Slab reinforcing details. See here, you can see this is a slab, this is a crank bar. These crank bars are which is called as the main bars, and this is the distribution bars which is going horizontally. Here you can see this is a distribution bar are straight. This is the main bars coming from the other side of the beam. This is top extra bar. This is the main bar. Slab reinforcing details. See here we are going to talk about how to do the slab reinforcement details. This beam is 225, that is divided by 2, that means the 500 mm beam. This is 300 by divided by 2. This is the length. This is a crank bar which is known as a main bar. Here you can see this has been going further down because this is 225, this is half is 225, the beam is 500. This length is 2950 mm. This is the main bar which has been shown here. This is the main bar. There is an intermediate beam. This is a 3100 mm. This is the edge beam. See we are talking about A1 to B1 side crank bars. See this is 225 by 12 divided by 2, that is 150. This is 150. This is L2. This is 42 degree. 2950, 2250. Okay, this bar. See, this will be 4730, 4580. So as an average is 4730.5. Length of the bar, that's the main bars, what I call it as. This is the main bar. Depth of the beam divided by 2 plus width of the beam divided by 2 plus 1 into inclined length minus 45-degree bend into 2 plus length of a shorter inclined length is equal to 42D. D is equal to slab thickness minus 2 side clear cover, that is the top and bottom cover. D is equal to 150 minus 2 into 125 is equal to 100 mm. Inclined length is equal to 42 into 100 will be 42 mm. 45-degree bend, that is a 1 dia. Diameter of the bar, 45-degree bend is equal to 1 into 12 mm intermediate slab, which makes 3100 mm. Length of the main bar, 300 divided by 2 plus 225 divided by 2 plus 1 into 42 plus minus 12 into 2 plus 2950 plus 300 plus 300 plus 3100 is equal to 4750.5. Cutting length of the main bar for a slab is equal to 1 is equal to 4.8 meter. Given data, so now what the data we have provided for a floor slab is as follows. Length is 2950 meter, breadth is 600 meter, beam size is 225 by 300 mm. Main bars are 12 mm dia at 150 center to center spacing. Distribution bars are in 18 diameter and 150 mm center to center spacing. Main bar and distribution bar differences. Top and bottom clear cover is 25 mm. Thickness of the slab is 150 mm. Therefore, to find its one way or a two way slab means LX, that is a 2950 mm, which is shorter span. LY, that is 6000 mm, that is the larger span. LY divided by LX is equal to 6000 by 2950 is equal to 2033. So it means one way slab, that is a LY divided by LX is greater than 2. So we have to need to find main bar for shorter band, distribution for a longer span, top bar for main and both side critical structure. See, this is the reinforcement critical details has been provided. Notes: main reinforcement bar is normally used at the bottom of the slab. Distribution bars are placed on the top of the main bar. Main bar is used in a shorter direction, but distribution bar used in a longer span. Higher dimension bar used as a main reinforcement bar. Lower dimension bar is distribution bars. Main reinforcement bars used to transfer the bending moment of the beams. Distribution beams are used to resist the shear stress and cracks developments at the top of the slab. Cutting length of the main bar for a slab 1. Here I show you the total images of the main beam. See, length of the main bar, depth of the beam plus 2 plus width of the beam divided by 2 plus 1 into inclined length minus 45-degree bend into 2 plus length of the shorter span plus width of the beam plus 0.3 into intermediate slab length, inclined length 42 degrees. See, here you can see that depth of the beam divided by 2. This is the depth of the beam divided by 2. This is the width. This is the depth of the beam divided by 2. This is the length of the beam divided by 2. Okay. 1 inclined length. This is the 1 inclined length. Minus 45-degree bend. This is a 45-degree bend into 2, because here 1, here 1. There is a 2-degree bend. And length of the shorter span. This is the shorter span. Plus width of the beam. This is the width of the beam. Plus 3. That is things. Into intermediate slab length, that is the intermediate slab length. Inclined length is equal to 42 dia. D is equal to slab length minus 2 side clear cover, top cover plus bottom cover, D is equal to 150 minus 2 into 25 is equal to 100 mm inclined length, that is 42 mm. 45 degree bend is equal to 1D. D is equal to diameter of the bar. 45 degree bend is equal to 1 into 12 is equal to 12 mm. Intermediate slab. Length is equal to 3.1 meter. Length of the main bars 300 divided by 2 plus 225 divided by 2 plus 1 into 42 degree, this is a 40 dia, minus 12 into 2, that is for a 45 degree bend, plus 2950 plus 300 plus 0.3 plus 3.1 is equal to 4730.5. So main bar 2 of the cutting length of the slab
Number
is
of
4.8
bars required
meter.
for
Cutting the main bar. Number of a bar is equal to opposite length divided by spacing plus 1. Opposite length of the bar is 6 meter. Spacing is equal to 150 mm as per the provided detail. That is 6000 divided by 150 plus 1 will make a 41. Okay. Step 3. Total length of the bar required for a main bar for the force 1 is equal to number of bar into total length of the bar, that is 41 into 4.8 is equal to 196.8 meter. Let us say 197 meter. So total length of the bar required for a main bar for the floor slab 1 is equal to 197 meters of a 12 mm rod. Cutting length of the distribution bar. Length of the distribution bar is equal to breadth of the beam divided by 2 plus length of the longer span, this is the length of the longer span, plus breadth of the beam divided by 2, this is the beam breadth divided by, this is a 250 beam, is 112.5. So how the calculation, length of the distribution bars will be 225 divided by 12, that is 112.2 plus 6 meter, this is the main bars, plus 225 by 2, that is a 112 point, that is 6225 mm. So length of the distribution bar is equal to 6225 millimeter. Step 5. Number of bars required for cutting the distribution bars. Number of a bar is equal to opposite length divided by spacing plus 1. Opposite length of the bar is equal to 2950. See here it has been shown. Spacing is equal to 150 mm center as provided detail. So 2950 divided by 150 plus 1 will make 21 number of bars. So distribution bars will be required 21 numbers of 8 mm toe. Step 6. Total length of the bar required for distribution of slabs will be number of bars into total length of the bar. 21 into 6.225 is equal to 130.725. So total length of the bar required for distribution bar of slab 1 is equal to 131 meters. Now cutting length of the slab 1. Top bar extra. Top bars are provided at the top of the main bars as the critical length is equal to L by 4. See here it has been shown. Okay. Number of top bars is equal to L by 4 divided by spacing plus 1. Number of top bars 2950 divided by 150 plus 1, that is 5.91. That means 6 number of bars into 2 sides. Both the sides will make it 12 numbers. So number of top bars, this is the things, okay, what I mentioned is a top bar will be 12 numbers. Step 8. Total length of the bar required for a top bars of a floor slab 1. Length of the top bar is equal to length of the distribution bars. Cutting length of the top bar is 6225. So total number of a top bar 6225 into 10, 27.25 mm. Hence total length of the top bar of slab 1 will be 63 meters of 8 mm rod. Floor slab 2. size of the floor slab is 1, length is equal to 3.1, breadth is equal to 6 meter. Hence, Lx is shorter span 3.1, Ly is equal to larger span 6 meter, beam size 225 by 300 mm, main bars 12 mm 150 center, distribution bars 8 mm at 150 center, top and bottom cover 25, development length is 40 dia, thickness of the slab is 150 millimeter. Therefore, to find the one-way or two-way slab, Lx is equal to 3.1 meter, that is the shorter span, Ly is equal to 6 meter, that is the largest span, Ly divided by Lx is equal to 6000 divided by 3.1 is equal to 1.93. Hence, it is a two-way slab. So, we have to find out main bar for a shorter span, main bar for a longer span, top bar for main rod and both sides critical junction. Step 1. Cutting length of the main bar for 4 slope to A2 B2 direction. See, here I show you all the details. Length of the bar A2 B2, okay, the direction is equal to depth of the beam divided by 2. This is the depth of the beam divided by 2. Width of the beam divided by 2. This is the width of the beam divided by 2 plus 1 into inclined length. This is the inclined length minus 45 degree bend into 2. So, 1, 2, 45 degree bend plus width of the beam. This is the width of the beam plus intermediate slab length. This is the intermediate slab length, what we call as the lap length which has been going through. D is equal to slab thickness minus 2 side clear cover, that is the top and bottom cover. D is equal to 150 minus 2 into 25 100 mm. Inclined length will be 0.42 into 100, that is the 42 mm. See, this is the inclined length, what I call as the 42 mm. Okay. 45 degree bend is equal to 1 dia. D is equal to diameter of the bar. 45 degree bend is equal to 1 into 12 mm. Intermediate slab, this is the intermediate slab. Intermediate slab, this is the intermediate slab which I am showing it as a 3.1 meter. Okay. So, length of the main bar A2 plus B2, okay, that is minus 300 divided by 2 plus 225 divided by 2 plus 1 into 42 minus 12 into 2, that is a 45 degree 12 dia bar. So, we have to do deductions plus 3100 mm plus 300 mm plus 3 into 300 is equal to 4580.5. Hence, cutting length of the main bar will be number of required bars for main bar 4.6. Number of a bar is equal to opposite length divided by spacing plus 1. Opposite length of the bar 6 meter, spacing is 150 mm. Hence, it will be 6000 by 150 plus 1 will be 41 numbers. Step 3. Total length of the bar required for main bar for the floor slab is 2. Number of a bar into total length of the bar, that is 41 into 4.6 is equal to 188.6 meter, that is 190 meter. Total length of the required bar main bar for floor slab 2 is equal to 190 mm of 12 mm rod. Step 4. Cutting length of the main bar for floor slab 2, C2 to D direction. See, here I show you length of the main bar C2 B2. See, this is C2 D2, this direction is equal to depth of the beam divided by 2. This is the depth of the beam divided by 2 plus width of the beam divided by 2 plus 1 into inclined length minus 45 degree bend into 2, length of the span plus width of the beam divided by 2. Inclined length is a 42 dia. D is equal to slab length thickness minus 2 side cover. Inclined length will be 42 mm. See, here everything has been shown very clearly. This is a 45 degree bend is equal to 1 dia. This is 6 D is equal to diameter calculation has been shown in the drawing. 45 dia bend is equal to 1 into 12 mm. intermediate slab L is equal to 3000 mm. So length of the main bar is equal to C2 minus D2 is equal to 300 by plus 2 plus 225 by 2 plus 1 into 42 minus 12 into 2 plus 6000 plus 225 into 2, that is 6393 meter. Cutting length of the main bar for a slab 2 is equal to 6.4 meter. Step 5. Number of bars required for a cutting bar. Number of a bar is equal to opposite length divided by spacing plus 1. Opposite length of the bar is 3.1. Spacing is equal to 150 mm center as per the details provided. So 3100 plus divided by 150 plus 1. So number of bars is 22. Step 2. Total length of the bar required for a main bars of the floor slab 2. Number of bars into total length of the bar. That is 22 into 6.4 is equal to 140.8, that is 141 meter. Total length of the bar required for a main bar is equal to 2 is equal to 141 mm of 12 mm rod. Step 7. Top bar, that is the extra bar. A to B to direction. Top bars are provided at the top of the main bars as critical length L by 4 area. Number of a top bar, that will be longer span divided by 4 divided by spacing plus 1. Number of a top bars will be 6000 divided by 4 divided by 150 plus 1. That is 11 number of a bars, two sides 22 numbers. Number of a top bars 22 numbers. See here, everything has been clearly shown. Okay, in this drawing the length and everything has been clearly shown. Top bar extra C2 to D2. Okay, number of top bars is equal to L by 4, spacing by 1. Number of top bars 3.1 divided by 4. Okay, number of top bars will be 14 number of bars. Cutting length of the top bars for floor slab D2. Total length of the bar required for tab slab is A2 to B2. See, this is the A2 to B2. Length of the top bar is equal to length of opposite bar, that is C2 divided by T2. Cutting length of the top bars will be 3.325 meter. It's been clear. Total length of the top bar will be 3.325 into 14, that is 46.55. Total length of the floor slab will be 47 meter 8 mm rod. Total length of the bars required for a top bar of the floor slab is equal to 2 into C2 divided by D2. This is all the beams. Length of the top bars will be length into opposite bar, that is A2 minus B2. Cutting length of the top bars will be 6.225 meter. Okay, which has been already mentioned. This is the longer span is 6 meter. Total length of the top bar will be 6.225 into 14, 87.15. Hence, number of a top bar for 4 slabs will be 88 mm of 8 mm rod. See, this is the total length 6 meter. This is 3.1 meter, which has been clearly mentioned. LY, LX, everything has been totally mentioned in this sketch. Result: floor slab 1. Main slab bars 185 mm meter of 12 mm rod. Distribution 131 of meter of 8 mm rod. Top bar 63 meters of 8 mm rod. Floor slab 2. Main bars 190 mm of 12 rod. Main bars 141 meters of 12 mm rod. Top bars 88 meter of 8 mm rod. Top bars 47 meter of 8 mm rod. C2B2. So total 12 mm rod required 516 meter. 8 mm will be required 329 meter. Total weight will be 12 meter. 12 mm will be 516 into 0.888 will be 458 kg. Total weight of 8 mm will be 329 into 0.39, 128.39 kg. Thank you for watching this presentation. Kindly subscribe and share, which will motivate me for a further good presentation. In case of any queries, do not hesitate to write to me. The response shall be at the earliest. Image courtesy, Google and various sites. You can contact me at civilconclave@gmail.com or at my Telegram group, Civil Conclave Telegram group. The link has been provided below. Once again, thank you for watching this.